Scene assembly lets you create, edit, and view large, complex Maya scenes without the huge memory overhead of typical large data workflows. In this example, I have a model, and I want to build or define different ways of interacting with it. Scene assembly is comprised of two interdependent nodes, assembly definition and assembly reference. An assembly definition is a node that acts much like a container to store and provide access to various representations of production assets. Let's take a look at how we can build an assembly definition of this obelisk model from our Hyperspace Madness game. By default, the assembly definition creates a locator. Let's rename it for visual reference in the viewport. Locator representations can be used as a placeholder for the object or production asset. Let's also give our new assembly definition a name, in this case, obelisk_AD. Representations of the model can be a simple locator for placeholding, a Maya GPU cached object for fast loading and optimal playback, or fully textured Maya geometry for detail and rendering. Let's add a scene representation, which in this case is the actual textured model. Scene representations are fully editable Maya objects that are saved in Maya scene files. Let's create some other representations of this model. Using GPU cache representations in your scene lets you quickly switch to a faster loading, lower resolution version of your scene assets as a stand-in for fully editable Maya geometry. Creating a GPU cache is easy. With the model selected, we'll export using .abc, which is an Alembic open interchange format. Setting up a scene with simple bounding box representations can also be utilized and increases playback, improves viewport performance, and decreases memory use, allowing you to work within the context of the full scene no matter how complex. The bounding box menu provides the choice of converting to a simple, single bounding box or into a bounding box per shape. We can even GPU cache the bounding box representation as well. Let's begin adding our new representations. Clicking Add Cache will select our newly created GPU cache. And then we'll do the same for the bounding box we created. Organizing data is simple as shuffling items up and down in the list, with the default representation residing at the top. We can toggle between various scene assembly representations in a variety of ways, via the outliner, or in the attribute editor, or simply by right-clicking in the viewport. So imagine the power of having a large scene dataset full of assembly definitions. That's where assembly references come in. We're going to load a small file as an assembly reference node. An assembly reference node allows us to combine assembly definitions into a scene. This is a simple city file which is only 70 kilobytes in size, yet with scene assembly represents a 3.5 gigabyte dataset comprised of assembly definitions. Let's select everything here and work with the GPU cache. Notice how I can continue to work in the scene, tumble, pan, zoom, etc., while the GPU caches are loading. This is important as it means no wait time, interrupting production, and it will load in the background. This is where the true power of scene assembly is utilized. Here we have a large scene with a variety of representations of objects. Of course, we can localize this down to the individual object level. If I want to work with representations of a specific area, I simply select the area and define how I want the data represented in my scene. Scene assembly combined with the powerful performance enhancements of Viewport 2.0 allows for interaction with very large yet manageable scene data in Maya. Autodesk Maya's scene assembly tools make managing the loading and manipulation of complex and large scenes simple and intuitive.